Okay, the talk tonight is on mineral habit. I'd like to begin by just reviewing a little thing about the Earth. Most of you know that the Earth, when it was originally formed, was entirely liquid. And it makes sense because asteroids have their own gravitation, and the asteroids being pulled to one another are eventually aggregated into something larger, and the larger something becomes, the more gravity it has. It pulls in more debris. And the impact of all these asteroids and astral particles create heat. And when something gets bigger, it starts to compress upon itself, and that generates heat. And because material has radioactivity, that generates heat. And the heat from these three sources cause the entire Earth to be a liquid rock, so to speak. It's basically a solution of maybe 100 or more elements just swimming around in the liquid. And I had a film for you, but we have no internet here, to show you how material, when it cools, starts to lose its energy, and particles start to grab onto one another, and solids are formed. Okay, that's the process of crystallization. Louder, please. Louder. So, crystals grow in this manner. And you can actually look at a crystal and see growth lines on it. And if you don't see any growth lines, it's very possible that that crystal was polished. And they're doing that nowadays. They're polishing crystals. Not only to make it shinier, but also to remove maybe things that are caught on the surface. And you have to be aware of that when you're buying crystals and you want it for your collection, to look for growth lines on the surface of the material. Okay, so every crystal that grows differently because it's got different chemistry and it's made of different elements. Different elements connect to one another differently and create different angles, and so the geometry of a crystal is based on what elements are present, and it helps you to identify it. The crystal shape is a tool that's used to identify what the crystal is. I have to say, color is the last thing you want to use because minerals come in every color. Diamonds come in every color of the rainbow. And if you go to the Museum of Natural History, you'll see in their display, they have a rainbow of diamonds to show you that diamonds can actually occur in every color. And mineral habit is the way that crystals grow in groups. So that can also be a tool to use to identify materials and their chemistry. Many times you'll come across materials that are so small you can't see what it is, but you'll see a grouping, and the way they group will help to identify what it is. So that's why grouping is a good thing to study, and it's just a matter of learning the patterns. Okay, so that's why I named this another tool, because we're always using different things to identify crystals and what the chemistry is. Okay. Definition: crystallization. Process in which a solid forms where the atoms or molecules are highly organized into a structure known as a crystal or crystal lattice. And some ways by which crystals forms are by precipitating from a solution, freezing, or more rarely, deposition directly from a gas. Attributes of the resulting crystal depend largely on the factors such as temperature, pressure, and the angle of the connection of one atom to another, and the element or elements present. Just a definition, but it includes pretty much everything. So realize that crystals can grow from a gas as well as a liquid. So both of them are solutions. And what happens is the swimming of the atoms in this solution is when they have energy. And because things cool down, they lose energy, and so they grab onto one another, and they grab in such a way as they produce an angle, and that's what produces the crystal's geometric shape. Okay, I had some things to show you, but I can mail these to you, and you can put them into your, what's that thing at the top?
Web browser.
Your browser, and that will produce crystal pictures and show you how crystals grow. And you'll see it's a liquid, and the crystals will go. But you'll also notice that when the solution starts to get down to a minimum, and you could tell in the picture that solutions are being lost by evaporation because they're time-lapse photography, you will notice that the crystals grow slightly different. What happens in nature is you have this solution and the crystals start to grow, and then you run out of elements. And then whatever elements are left in that solution will grow new crystals. So you'll find crystals growing on top of crystals, and there'll be whatever's left in the solution. So that's why you see crystals on top of crystals. And the more crystals you see, the more interesting the specimen becomes. So I'm just going to skip this because of the lack, and if you want me to send it to you, I will. But you could probably look it up yourself. Just look up crystallization and you'll find all these things. I use them to get kids excited about crystal growing. Okay, so there are common tests that you would use for identification of a mineral. First, hardness. Hardness is probably the most important thing because that's how you find out whether you have a gemstone or not. All gems are hard, and they're usually above 7 because 7 is quartz, and a lot of the common things which are considered semi-precious are 7 or around 7. But 8, 9, and 10, the hardness is not just evenly 8, 9, or 10. 8 is much higher, 9 is way higher, and 10 is way up there. So it's a geometric scale, the hardness scale, all right, which is something you can have a lecture on just all by itself. Luster is a very important thing because very often you just have to turn the specimen and see how it bounces light off, and it will indicate something different because there's so many different kinds of luster. And we could do a talk just on luster. In fact, we could do a separate talk on each one of these things. What I decided to pick out today was the one on habit. The way something breaks, fracture and cleavage, the crystal shape, and there are like 8 different systems. Fluorescence is another thing, how it reacts to a hydrochloric acid or something you can carry with you. Surface features are important. Inclusions, notice colors all the way down at the bottom. And then you have associations and magnetism. There's so many tricks and tools that you use to identify a mineral. The problem is when they get real small. And I did some research for my thesis on comparing sands from New Jersey to Ronkonkoma, Long Island. And when you're dealing with sands, it's just a grain, and you're not going to see crystals because sand is usually beaten up stuff that's reduced in size. And so what I had to do, I did through magnetism, and I did through habits. And I graphed weights of all these different things after I separated them by their magnetism, and I produced charts to be able to tell what the sands look like mathematically. And I was able to compare several things, and I invented a new system for being able to tell what one sand was compared to another sand. They loved it. They wanted me to publish more, but I got tired.
Well, magnetism, what do you mean? It's either attracted to a magnet or not? Or
no, it's more than that, because there are everything is pretty much magnetic. It's also like saying everything is soluble. It's true, there really isn't anything that's not soluble, except maybe some man-made materials, but everything is soluble to a degree. When they say something's insoluble, they mean you don't see much of it dissolve. But seawater pretty much dissolves everything. There's plenty of gold in seawater. If you could evaporate enough seawater, you'd be rich. The same thing is true with magnetism. Everything is slightly magnetic, and to a degree, a little bit more and more and more. And you can group them according to how magnetic they are, and in doing so, you can separate grains of sand based on their magnetism, and that's what I did for my thesis. But things are not just magnetic or non-magnetic.
It wasn't
It just doesn't work that way. Nature allows you to have partial. It's the same thing with magnets. Have you ever noticed that some magnets are strong and some are weak? Mm-hmm. Well, it depends on how many atoms are arranged in the same direction. If some of the magnets start to turn this way, the magnet gets weaker. These groups of atoms that are all in the same direction are called domains, and depending on what happens to those domains in the formation, something can be weaker or stronger magnetically. Yes,
You don't have radioactivity up there as a feature.
I try to stay away from that.
We all do, but
It's a good thing
would
to
that
have.
be considered a feature of the?
Yeah, you're right. I didn't, it's not complete. That was the last thing I was gonna say, is that this list is not complete. You'll find other things that you wanna use. I have a Geiger counter at home. It's always good to have one, and I found a lot of things I did not think were radioactive, and they were radioactive. So I put them aside somewhere and just keep them away from the normal traffic. But it's good to have one. How many of you have Geiger counters? Oh, see, there's a few. Yeah. And you use it all the time, right?
Used to at work.
Okay.
Used to handle radioactive materials on a regular basis.
Uh-huh. Okay.
Professor, what about inclusions? How are they actually?
Certain materials are more prone to have certain types of inclusions. For instance, you'll find bubbles of water in quartz more often than any other mineral. The anhydrous crystals.
It's actually water inside the crystal.
Oh yeah,
Yeah. So if you drilled a hole, you'd have
yeah.
water from
Yeah.
the beginning of the earth.
Roman will do a talk on that one.
So you
But like I said, there's a lot more.
Hydrocarbons too inside quartz,
Yes.
that gives quartz some, some quartz real fluorescence.
I was only using an example, but there are many things found in quartz, as there are in diamonds, right? That's, as a matter of fact, some of these inclusions are a way of identifying a particular specimen.
Location, or
Yeah.
location, yeah.
Okay, yes, or location, right, okay. So it comes in handy. All of these things are things that you would use. Now the habit is in general, the general appearance of a mineral crystal or group of crystals. And there are many growth types. They occur commonly for the same mineral, and so they help in its identification. So I have a little handout which shows you all, not all, again, there's always something missing, but these are patterns that you look for certain minerals. So I'm gonna hand that back, hand these back, hand it back, hand back, okay, hand these back, So these are common habits.
Oh, wait, this one in the back here.
There you go.
Oh, they got it? Okay, good job. Yeah, they're not good, they're good. This one.
I joined the Art Society.
Nice artwork.
Okay, now I'm going to be showing you examples of these things, and we're going to go through them, and then we'll do a little test, see if you can, that's my way, to see if you can apply what you've learned. Okay. First we have what's called the massive or granular habit. This is very common in certain things. It's very sugary, it's like sandstone. What happens is the crystals are growing and they get in each other's way. Space is what really is important in the growth of crystals, because if a crystal stops growing and there's still space to go, you get to see the crystal shape. If it continues to grow and it reaches the next side or another group of crystals growing, then you end up with obliterating the geometry, and this is what you end up with. Each one of these can be a crystal, but they just got in each other's way. So this is called massive. Kind of looks like, I guess the best example is looking at a sandstone. The grains are just packed right into one another, and you don't see any possible flat sides. Okay, most of the time people call this massive. When you can't see any crystals, massive is a good term to use. Okay, lamellar or micaceous. Most of you know that mica occurs in very flat sheets, and you can peel them one after another. The crystal shape, however, has nothing to do with this. This is the way the mineral displays its cleavage. The crystal shape of a piece of mica is hexagonal. If you take a pencil, which is hexagonal, that would be the crystal, and the cleavage occurs at right angles to that. Like slicing up a pencil, that would be the cleavage of mica. So they showed you a hexagonal shape here, and this is the way it cleaves. So this is a possible way that crystals can grow together. Okay? Lamella or micaceous. Bladed or plumose. Most people don't use the word plumose anymore, but I just love the word. And bladed just means that it's got a flat, long crystals grown together. This it can occur in stilbite, kyanite, antiquarite, if you know the minerals. You picture it in your mind. There's a little picture here. This is probably more, this shape looks more like stilbite. Kyanite is probably
Would it
flatter
be
at the top.
barite?
Say it again?
Would it be barite also?
Barite, yes.
Okay.
Okay, bladed. Also, there are feldspars that occur in blades. Most people, do you know them? One that's, I'm trying to think of the name. There's 10,000 minerals. It's really hard to remember them all. Does anybody know the bladed feldspar? Nobody, huh? All right, it happens. What happened? Oh, I'm sorry, pressed the wrong
Just as
one.
a throwback, Vivianite is the most.
Is what, bladed? Okay, Vivianite, yeah. All right. Fibers. And sometimes the fibers can be soft. And sometimes they look soft and they're not, and they're hard. But most of you know asbestos. And the asbestos was common in the C.K. Williams quarry. It's part of the serpentine groups. And of course, you can see that the top part of this looks a little bit micaceous as well. But that doesn't mean it's always right angles that way. But fibers for those particular minerals, chrysotile, asbestos. By the way, they're one and the same. Chrysotile is asbestos, right?
Well, asbestos is a general term, it's not a mineral.
It's not?
No. Chrysotile is asbestos form, tremolite can be an asbestos form. You know, it's,
Would tremolite be bladed?
tremolite can be
Fibers
massive.
also?
Tremolite can be massive.
Oh, well, you see,
Some of the stuff, a little bit at C.K. Williams is asbestos form.
okay, so let's just say that one mineral can have more than one habit. Just depends on how much space it has, how big it grows, and so it might look different in different cases, but this helps. This is quartz in its acicular form. It has very thin crystals, very long crystals. This happens with things like strontianite. They're just very thin. Even calcite can occur in thin, long crystals.
Stibnite?
Say again?
Stibnite?
Stibnite. Would that be bladed? Stibnite? Well, it could have in both forms. If it's thin and small, it would be considered acicular, or it could have bladed also. So again, one mineral can have more than one habit. Okay, the important thing is to remember, okay, that it's not just one thing. This is orbicular. Anybody recognize the mineral?
Agate?
Say again?
Agate?
Nope.
Jasper.
Yes, it is a jasper. Okay, do you know which one?
Oh.
It's the one from Indonesia. Very bright yellow, orange.
Bumblebee.
Bumblebee jasper. Yeah. Isn't that a beauty? Okay, then you have a radial form that forms a rounded tops, kind of like half grapes, or sort of like a reverse raindrop. This is common in pectolite, prehnite, wavellite. If you know the minerals, they always occur to these like radiating structures, and they grow from the center outward, okay, and they fill in. I guess you could also say naturalite does that, but naturalite starts to separate, and the crystals grow at different rates of speed. So that's one of the things that helps you to decide whether something is pectolite or naturalite, because they look almost the same when they're small, and when they grow, the naturalite spreads out and gets longer and shorter crystals, and the pectolite stays the same growth rate.
What about oakenite? From India.
Aukenite is also a secular, yes.
Okay.
Although, again, aukenite can occur as something else. If it's very young and there's not much to it, it could be just a druze or a thin little layer of it. Okay, then there's also the cubic habit, having right angle geometry, common in halite, fluorite, and galena. And the groups don't have to look like this. They don't have to be interlocking. They could be actually separate crystals. Easy to remember, cubic.
Pyrite also, I would assume.
I'm not reserving any names. The test comes late. Wait.
Oh, okay.
I may show you something else with cubic, and then you have to remember. Oh, it is cubic. All right. We're looking at the shapes and going to associate them with pictures later, right? Dendritic is like a tree form, sort of like when you're drinking too much and you can see your red eyes and you see these lines coming in from the sides. Or the veins in your hands when you're drinking too much, red eyes.
Does that ever happen? You
Not me.
No.
But this is a typical manganese crystal. And you probably have seen it in many rocks and many quarries. Okay. Pyrolusite is one of the manganese minerals. There's many of them, tourmaline, and there's a whole suite of manganese. By the way, manganese is very common in Pennsylvania for some reason, and everybody has it in their water tanks. It's a very neutral material, and they say it doesn't affect the water you drink at all. But if you look at the bottom of your tank or try to clean out, you'll see pebbles of black that accumulate at the bottom of your water tank. I've noticed that. Okay. Are you looking at the paper and finding these and where they are? Okay. Just so that you have
Yeah,
a
what was the honeycomb?
It doesn't help with it's upside down.
What was the honeycomb one, back when we said agate?
Say it again?
When we were calling the one agate, and it was the honeycomb.
The bumblebee jasper.
Jasper.
Oh, the orbicula? See, that's something I left out.
Uh,
There's always something missing. And I put letters on the side here so you could just review which row it's in, make it easy for you to find. Okay.
I think it would help to have actual pieces.
Just remember the pattern is under the name, okay?
Right.
So dendritic is at the top. Orbicula is missing. Although you could say it's part of what's down at the bottom where it says reniform botryoidal. Yeah, it's also radial. Okay, then you have the reniform. Mammillary is another word that's used, botryoidal, common in hematite and chrysocolla and many other materials. Okay, it's just that rounded groups at the top. I'm reserving myself because I'm almost giving you answers ahead of time. I don't want to do that. But you could see it at the bottom. The pictures just show you the rounded edges, and I tried to show you that it could be small lumps. It could be larger lumps. I found many minerals like this in Mexico when I did mining work. When they're like that, it's really difficult to tell what they are because they all look the same. Then you have stalactites or stalagmites, and this is very common in travertine or things that are dripping from caves. Just another group of crystals. And then you have other habits that I did not have on the sheet. Amorphous, arborescent, which is dendritic, another word for it. Reticulated, that's the top of the sheet. Reticulated is crisscross needles. Look at that picture, top A to the right. Then you have chevron, that's row B, the first one in row B is chevron. You have parallel or linear, which is very common sometimes in bladed material, and sometimes hexagonals have that as well. Parallel. Then you have platy or tabular, which could be very similar to platy. Wait a minute, platy. It could be similar to what was I thinking of?
The bladed?
Bladed. It could be, except that it's not long. They could be wide. Okay, plates are tabular. That's it. You were talking about. a mineral before, you said, was that,
Barite?
barite, it's
Okay.
more platy and tabular, yeah. And quartz can be tabular. Sometimes
Yeah,
quartz
quartz.
has a growth that's in one
Yeah.
direction more than another, it just turns out flat.
How about
Like Himalayan
Celeste
quartz.
type? There's some bladed celestite.
Yeah, well, celestite has 5 different
Yeah.
habits, so.
What's the difference between platy and lamellar?
Okay, platy and lamellar. Lamellar is probably much thinner. And you know, sometimes it might right be on the borderline. It's like saying, okay, I'm going to divide everything into what's larger than a bread box, what's smaller than a bread box. What if you find a bread box? Then you can't put it in those 2 categories. Well, the same thing's true with platy and lamellar. Sometimes it's right in between, and you can use either term, as long as you know what you're looking at. That's the important thing. Just a helpful guide, all right? The conchoidal is a shell-like, and that's the row C, first one in row C, similar to the way a shell looks on the inside, and botryoidal is, again, grape-like. I have a whole series of minerals that I found in the Baja of California, which all look like grapes, and they're all different forms of hematite, agates, chrysocolla, they're all combined in the same thing, and they're all little round balls. Beautiful specimens. I mailed them back to the miners in the Baja, and I said, get me more of these, and I never got anything back. Boy, I was mad about that. I wanted to show them what to look for. I don't know, they probably never went back into the field after that.
And they kept the ones you sent?
They kicked the ones I sent them.
Why did you send them a picture?
They sold them.
I should call them. Okay. Come on, get out of here. All right. All right, so now we're going to apply what we see. That's why I gave you the handout. You look at the pictures that follow and apply one of these habits. Some materials can display more than one habit. Get that right on the thing. You can even see in these pictures that you can apply more than one note. Okay, kyanite. What's the habit we show? That's an ugly kyanite, isn't it?
Yeah.
Linear?
Say again?
Linear.
Linear?
Linear? Do you think so?
I say reticulated.
How about the rest of you?
Reticulated.
Reticulated.
No, not reticulated.
Lady? Oh my goodness. Bladed.
Bladed is the one.
Bladed.
Yeah, bladed. Bladed. Kyanite is bladed. Kyanite usually are common forms of the blue. Everybody loves the blue. And the black. We see a lot of black. But this color, I don't know where that one came from.
What is kyanite? What type of
Mud.
chemical?
Looks like that.
Yeah, it does look like mud.
What type
But
of chemical?
kyanite is usually a mineral found in metamorphic rocks, usually under pressure. And usually they're all pretty much in the same direction. Boy, that does look ugly. But that's why I picked one you didn't see. You don't see
Looks
too
like
often.
that.
Some minerals are ugly.
I know that one.
Okay? What's the mineral?
Goethite.
Say again?
Goethite.
Goethite?
They say goethite.
Hematite.
Oh, it's hematite, okay.
Well, you know something, goethite is a kind of hematite. It's just
Yeah,
instead of being
sort of.
Fe2O3, it's Fe3O4. What's the difference?
Yeah.
A few atoms here and there.
What do you say that is?
Say again? It's hematite.
Hematite.
And I have to tell you, this is not always so beautifully round. Sometimes it's much gentler.
And it's heavy.
Yeah. It is heavy. It's iron. Okay. But you see how it applies, right? Now this one, I should try to enlarge. No, it's not working.
Fibrous?
Yes, it's fibrous and also acidic, both, because they're very thin crystals and very small, and it helps. Anybody know what it is? I have to tell you, it's covered a little bit by hematite. That's why it has an orange color. But that's just a stain on the surface. If you look past the color, you'll see that they're right about here. You could see very small crystals.
Aragonite?
No, oh, very good guess, but no.
Or calcite?
These are
No,
strontianites.
Strontianite.
Yeah. Strontianites from Winfield Quarry. We found a giant boulder that was covered with them, and everybody attacked that boulder from every side.
Yeah.
And I just picked up pieces.
That used to be a quarry, I don't see it anymore.
No, they closed it.
Yeah.
They don't let anybody in. It has
It's right
wonderful
next to
stuff,
the,
wonderful stuff.
Mount Pleasant.
Bucknell University Geology gets to go there. That's
Oh,
all.
So you have to go to school.
Oh, okay.
They'll let you in then.
Well, you're good.
You have to matriculate. This is a gold nugget. Isn't
Wow.
that beauty?
Ah,
Now, if you found that, would you realize it was gold?
ah,
Almost looks opal.
It looks like what?
An opal.
Really?
wow.
Wow, that's a
Well,
beautiful
you'll
opal.
probably figure out it's gold fairly quick because it probably weighed a bit.
That's right, it's heavy. Plus, gold is malleable, so you'll be able to press into it without breaking. It's an element and it's metal. Most elements that are metal are malleable, so it's easy to tell. That's why in the old movies, everybody took the coin and put it in their mouths and tried to get a tooth mark in it to tell it was gold.
Oh, yeah.
In those movies, those cowboys were smart.
Oh, wow. Chevron.
That's a chevron, and that's an amethyst.
Yeah.
That's what Charlie.
Isn't that beautiful?
Boy.
Now, this happens in the crystals too. We have crystals that have those chevron, okay? Pectolite tells you what it is.
Radiating.
Radiating, good, okay. You catching on?
Yeah.
All right.
I just want to tear.
Another
this
hematite?
bag open. That's it. Thank you.
Do you notice it's slightly different? It's not the same. It's, you see, there's a big gradient of how big those loops are going to be, or those droplets are going to be. They could be very big, or they could be very small. Just to show you a little variation. Here's another strontianite. Probably this one is easier to see the acicular form. Just sprays coming out. Yeah. Oh, what's this doing? All right. And prehnite is one common. By the way, there's a prehnite in the auction with, I just found little cubic pyrites in it. Okay, so what is this?
Botryoidal?
Yeah, it could be a botryoidal, it's a form, but you know what it is? They tell me that most people will use the word druze because the crystals are very small and they butt up against one another. And if you see the area where it's broken, which doesn't show it in this particular specimen, you'll see that the crystals are all lined up and they're all teeny. And the way they described it in my mineral class was it was druzy.
How do you spell
Druzy
Druze?
prehnite. D-R-U-S-Y.
Like the religion. Like the religion.
Druzy is not in the list, and that should be added to the list. It just means very small crystals.
I remember, that's something.
But Robin will tell you it means something else. Because everybody learns it differently. Small crystals to me are just druze. And sometimes it makes it hard to identify them.
I got a druze in the grab bag tonight, if anyone wants to look at it.
Okay.
Congratulations.
Well, Nina, I remember Nina so often talked about druzies.
Yes.
Isn't that a beauty?
Druzy.
Oh, yeah.
Wow.
Silver precipitated in the lab. Just happened that way. And how does silver appear in a rock? Remember, this is laboratory created. Anybody know?
Isn't it
Lines.
actually
Fibers.
5 lines.
Well, yeah.
It's called filiform. See, that's another one I didn't even put down. Filiform means things look like wire. Copper can do that, silver. Sometimes it actually curls.
Like, well, somebody got them, I guess it was magnesium?
I get that.
You got that?
Yeah.
I first thought it was silver, you know, I saw it. That's really pretty.
Yes.
How do they
I
break
have
this
large
silver out of the
clusters.
ore?
I'm sorry?
How do they break the silver out of the ore?
How do they break it?
Yeah,
First you take
you're-
the
you
ore
have a
and
silver
crush
mine.
it. First you crush it and then you heat it up and the silver will run out at a different temperature.
They use mercury for that also.
Well, you gotta be careful with mercury, it's dangerous.
But that's how.
We worked with mercury for gold,
That's how
and
they
we
do it.
lost the gold totally. We heated it up too much and the gold did evaporate. I've never heard of gold evaporating, but there was no gold left when we finished.
Oh my goodness. What?
We almost got killed.
Oh, wow.
We were out west and, an old story, and some guy said, "You want to cross the border?" We said, "Oh yeah, just hide it in the mercury. Mercury will dissolve gold or some metals, and you can always bring it across as mercury across the border, and no one will know you have gold." And then we got to the whole thing was we wanted to show them that it'll come back out of the mercury. So we were using a distillation process. We heated it up, probably too hot, and the gold evaporated. There's no gold left.
Oh my God.
So it's mercury is a dangerous product to work with, especially if you don't know when you got it too hot. We were out in the desert doing this kind of stuff, so it happens. All right, this is silver. I guess you wouldn't say it's filiform anymore, but it's certainly some kind of botryoidal or reniform. Are we going backwards?
Yes.
Yeah, you are.
How did I do that?
Happens.
That lunch tonight,
Oh.
back at the beginning.
How did I do that?
Come
Wow.
the wrong way, Doc.
Other way. Now you're back at the beginning. Let's start over.
Start at the end.
I'm not doing anything different.
Must be your energy.
I don't know. Sorry.
Okay.
Okay. Quartz and we got galena and pyrite all together.
Circular.
Yep. You got quite a few here. You got your cubic habit, you got your acicular habit, depending which mineral you're looking at. But it should be easy enough for you to identify them. Do you know what country this comes from?
Peru.
Peru is correct, right? This is very common in Peru.
Wow.
These three minerals together. And quartz all together, wow, a blue quartz.
Wow, I didn't see that.
Now the habit is tough.
Granular.
Yes, this is granular or massive. See, you don't see anything, all the crystals grew into one another. There's a good time to use the word massive. Anytime you don't see any crystals, it's massive.
Would granite be considered granular too?
Granite?
Yeah.
Absolutely. Yeah. And if the grains are too large or half inch larger, what do you call it? Pegmatite.
Wow.
Pegmatitic is also a situation where your crystals are over half inch, all of them, over half inch in size. And that happens with very slow cooling.
Would it be a nice also, or it has to have different?
And you mean granular?
Yeah, like the pegmatite, the granular.
I would call it more lineated, because that's formed under pressure
Oh,
from two different directions, and everything turns in one direction.
okay.
Still bite.
Conchoidal?
The problem is you don't see one single crystal, they're all bunched up together. But if you know still bite, you know that this is bladed. But see what happens when the blades lay down on one another? Gives you a different impression. But you have to keep turning things around to find one blade by itself. And it just looks like a brain. It has also, it forms bows. It radiates a little bit each time one of them grows, and sometimes in some specimens, the best specimens, it's a complete bow. That's the one that you want for your collection. It's a complete bow. This is a combination of bows put together, so you don't really see one bow. Scoliosite.
Oh, wow. Acicular.
It's circular, right?
Yep. In a spray, acicular. Always separates. Scoliosite always separates itself. Oops, it's doing that again. Go away, go away.
Push it down there.
Naturalite. Now here's what I showed you before, the pectolite and the naturalite. You see how similar they look? But when you look at the ends of the naturalite, you'll see that they're all different lengths because the crystal is growing at different rates of speed. And that's what helps you to separate, in the field, what a pectolite is, what a naturalite is.
Is that sodium from natrium?
Is it?
Is it sodium natrium?
I don't remember. All I remember is the lemon soda. It's a zeolite. Yeah.
Zeolite.
By the way, the grouping of zeolite are minerals that have very complicated. Oh no, I'm talking of something else. Oh, they're complicated structures enabling them to become good filters because they allow water through, but they'll catch other particles. So very often, companies will take these minerals and crush them up and use them for water. So we lose a lot of stuff to industry. Wow, look at this. 2 different ways to show a spray, large and small. The sprays in here, a little
That a
circular.
circular quartz?
Yep, and it's quartz on quartz.
Wow, I have a piece like that.
And you would be surprised how common this is in Pennsylvania quarries.
Yeah,
When
really.
you don't see anything, look for this. You'll find it. It's
I
usually
actually have a
there.
couple pieces like
Yeah.
that.
Yeah.
I was once, I think it was Sellersville, and everybody was looking for epidote. I found a ton of this.
That's where I was born. Oh, wow. Reniform, right?
It could be reniform, right?
The
Could be
black
mammillary,
tree.
reniform. What mineral?
Chrysocolla.
Chrysocolla. Yeah, it's a copper mineral. Still bite?
Still by.
See, here's where you get to see a little bit of the bowl. It expands from this side and then that side. See the bowl in the bottom there? It goes
Is that
wider.
a circular or
Well, it's still bite, so it's going to be
bladed? A
bladed.
circular?
Bladed.
Also bladed,
But their blades put together. You have to really look closely at it. And sometimes they're very small.
yeah.
And anybody know what the white material is in between?
Lomentite?
That's correct. Lamontite, if you look at those crystals, they seem to be very fragile. They fall out real easy, so it's easy
Yeah.
to tell them. And they're short, stubby. They have a long axis, but this stuff, it'll be in your hands. And you'll know right away. It's just very,
Yeah.
very fragile stuff. Oops. Is that on the screen?
Wow.
Okay, it says azurite, malachite, and chrysocolla, and you'll notice they all have a very similar habit. It's all that battery oil. And
A circular battery oil?
do you know why they occur together?
They're all copper.
They're all copper, a lot of copper, different degrees of copper. And they're carbonates, aren't they?
I think one's a carbonate, one's something else.
Well, what we learned in mineralogy is if you have the azurite out there and it weathers, it will turn green. It becomes malachite. There's a progression. We were hunting the chrysocolla because in the place we were in, the chrysocolla being normally a brittle mineral was filled with silica. And that meant that it gave it a lot more body. And you could cut it and shape it, and it was a gemstone, and you were buying it up like crazy. I found about 800 pounds of it. And I took 60 pounds on a plane with me back home, and I brought, I think 30 pounds at a time to the shows, to the vendors, and they were buying it from me for $15 a pound. And when I went back to the show to see what they were selling it for, they were selling it for 99 cents a gram.
Oh,
Well, I learned a lesson.
Is there a difference in weight with the azurite and malachite?
Not much,
no.
not much. You have the same atoms, they're just
'Cause they
changing their
look
positions.
like, one looks harder than the other.
Well,
Pieces like
no,
that.
not really. They're very common in a lot of the properties, except for the color and because it's changing its chemistry a little bit. But it's using the same atoms.
Where did you find it, Professor?
Which
The azurite?
I found mine in Santa Rosalia in Baja, California, about 12 hours down from nice city in the United States.
San Diego.
San Diego, yes. My base of operation was in San Diego, called Pine Valley, and about 40 miles out of San Diego, and then we went straight down Route 1 along the coast down to the mines, the Copper District, which is a long drive, and the cliffs that we passed on the left, as we were going down, the ocean was on the right, Pacific. The cliffs on the right were separated into two layers. The bottom layer was Devonian and Cambrian layers, and it had a lot of shell fossils, and everything on the top had hadrosaur bones. And at that time, they wouldn't let me collect anything because we were doing work. We were doing we were looking for crystals of boleites and pseudoboleites, copagites, very rare materials in the mines in Santa Rosalia. And we did. We found one. We knew where they were, just had to dig them up. So we found that they were down in about 300 feet underground, which is stifling. And then the layer, we finally traced it, went up to the surface, and we were able to pick them up off the surface. But it was grueling 3 months. And I don't think I'll go down there for that long again, because my stomach just didn't do well.
Wow.
Rutile. Yes, this is reticulated. We've been looking for this one. It's at the top of your sheet, crisscross. Rutile's not the only one that does this. Has that crisscross nature. There are quite a few. White calcite, look at those.
Wow.
Calcite appears as everything. You gotta be careful with calcite. The best thing to have with it is hydrochloric acid, because it'll just bubble up pretty fast with calcite. But what are those orange things?
That would be gold, I would believe, wouldn't it?
It could be,
Gold and
but gold is usually associated with quartz, not calcite. Orange, think orange. Not too many with orange. Anybody?
Hematite,
Yeah.
It's wolfenite.
wolfram.
Whoa.
Wolfenite. Okay.
Didn't see that one.
More manganese minerals, a different form. What happened?
Is that granular? Granular?
No,
Or reniform?
no,
Well, what?
don't guess, look.
Fibers?
Tree-like,
Oh, dendritic.
dendritic.
Okay.
See it? Can you see the
Yeah,
tree?
tree-like.
And remember, we saw this before manganese, right? It was in this shape. Oh, sericite, look at that.
Wow.
Reticulated again. And there are quite a few lead minerals that do this.
It's like Japan Law Twins, something like that.
Twins is another story.
Oh, okay.
Yeah.
Oh,
Ocean jasper. Remember we saw this for the bumblebee. It's not on the list.
oh.
You have to write that in down there at the bottom where it says reniform. What happens is you get these microscopic seeds, which could be fossils or crystals, and then everything grows from that in the same in all directions and forms these circles. And the ocean jasper is known for that. And the ocean jasper, we just came across some ocean jasper for some butterfly wings. They're coming out of China. They're doing a great job in polishing and shaping wings and putting it to a metal base. And you don't happen to have any here, do you? No. And the ocean jasper is amazing material.
So wait, so what was that listed on?
That was orbital. Orbital.
It's not on our list.
It's at the bottom. Look, orbital.
I see it. Oh,
At the very bottom.
Okay, yeah.
Okay, it's there.
So we did say reniform, and you said no.
You did?
Yeah.
I didn't hear no written from
Yeah,
outside.
yeah.
Was it orbital or reniform?
Or.
Hey, look, when I play, I'm always next to a drum. My hearing just is
Below
going.
it.
Orbital means.
Okay, this one is obsidian, a snowflake obsidian, and
What triangle means.
It's what?
See that, get that attention.
concordant, yes.
Professor, hold on a sec. Go ahead.
But reniform is from rena, which is your kidney, like renal failure, right? That's what reniform means, from kidney-like. And then
Renal,
botryoidal,
but you don't have to associate those two prefixes.
and then botryoidals from the Latin or Greek meaning clump of grapes, and then orbital's your eye.
Okay,
And then reticulator is from neck. That's what reticulator's from. the
From
old
what?
word
Net.
Net.
Next.
N-E-T?
It's an old Latin word for net.
Okay. You're up on your Latin, that's good.
Plumose is from a feather.
I forgot so much of my Latin.
Like a plume, a plumose is from a feather.
Yes.
That's what it's from.
Okay, then it becomes easy for you, but not everybody has that
If you
point.
know
At
where
6
it
years of
comes
Latin.
from, you can associate it better, right?
Yes, you can. You can. So this is the obsidian. You see the shell-like fracture. Whoa, beautiful. Yep, it's all little right there again. And that's another ocean jasper. Look at the people. Look at the people.
Chevron.
This is in my book.
Chevron.
This is my geology book. Those are chevron folds.
That's huge.
Wow,
Look at the size of people there.
wow.
So it doesn't necessarily have to be a microscopic thing in the mineral. You see how large these things can
Where is
become?
that?
Now, why does that happen? Anybody know?
Very slow. Very slow, cool.
That's
I don't think it has to do with cooling. It has to do with compression.
Compression.
Things have been compressed, and what happens is what was in the layers were platy or lamellar materials, and then they don't bend that easy. They do this. Okay, they keep their shape. So compression wasn't able to bend them, and they produce this thing. And the same thing happens with the minerals that are producing chevron folds in them. Is that there's something in there that holds its shape and won't bend. So
So it's like a paper fan. Where you
Where
they
bend it.
V-shape.
Where is that?
Where is this? I believe California.
Wow.
Naturally, there's a lot of earthquakes and compression. Want to go visit?
Yes.
Field trip.
Yeah, there you go. Let's plan it.
Paper.
Okay. Reticulated.
Okay, again, you're catching that one fast, right?
Yeah,
Yeah, that's easy.
okay. That's
Oil.
Okay, so what mineral?
Great maggot.
That's your grape agate. Yeah,
Great. I want a piece of that. I got from you, I think.
that's good. Yeah. All right. Well, I'm finding a lot of it is around now. There's a lot of grape agate. So now you have to look for better quality ones. You know, more purple. The ones I look for are the ones that grade from green to purple in the same specimen.
Yeah.
Raw.
I have both of them.
I like to see the change in color. I like to see the
Yeah,
change in environment.
See,
I invited my neighbors. over
Okay,
to
I just want to point out that there's more to have it than what I've listed. It's just to get you used to using groupings as a way of identifying things. And you'll notice a lot of the same minerals have a lot of the same habits, and it is possible for something to have more than one habit, depending on, like it said in the very beginning about crystallization, a change in pressure, temperature, and what the chemistries are. It'll always be unique. And the Earth has so many different environments that it always comes out a little bit different. That's why it's easy to tell sometimes where something's from. If you look at a prehnite from New Jersey and a prehnite from New York, you might see there is a difference between them, and there are certain localities where prehnite is very unique in the way that it grows. So you know, oh, that's from the pumping station in New Jersey, and the pumping station prehnites are different from all the other prehnites.